Bayar, Bayar.
He's coming, Baba. He's coming.
Okay.
Hello.
لا حبيبي هلا.
He's coming.
Okay, okay. Can you see my screen? Roj,
Yes.
what do you see on my screen?
Yeah.
Just tell me one word.
Light.
Okay, okay. You don't need your camera, Roj.
نعم.
He doesn't need camera. I don't want to see يعني.
Okay, Baba. Okay.
ما
حاجة تسأل.
ما يحتاج كاميرا يعني. Okay, are you ready?
شوف ماما. Do I use a book?
Yeah, if you want to write any notes, if you want to write any notes.
Yeah, yeah, I would like to. Mama, اكو قلم. Oh, there's. Yep. Stuff.
Is my voice clear?
Yes.
Okay. You ready?
Yes.
Shall I start?
Yes, you should.
Right. So we doing, as you know, we're doing physics. We're
Yeah.
doing physics. Right. So the first thing we need to do is about something to say about light. So
Mm-hmm.
we're saying light is a form of energy. So remember this keyword, energy. So light is energy. Okay. So light
Mm-hmm.
is of energy. It says especially electromagnetic radiation. The type of light is called electromagnetic radiation. The thing is, they call it electromagnetic because if you're listening carefully, because light is like two components. One is electric and one is magnetic. So it's like two things combined to make light. So that's why they call it electromagnetic radiation.
Like,
Electro
okay.
It says that it travels as wave. Remember this keyword, wave. So you have
Mhm.
two important keywords in this definition. One is the energy and one is wave. So light is an energy as it travels as wave.
Yeah.
And light is is one portion is part of electromagnetic radiation, the one which we can see by our eyes. Okay? Is that clear so far?
Mm-hmm.
So remember this
Yes.
energy, and waves.
Yes.
These are the two keywords. I'm going to highlight it for you.
Okay.
Make it
Okay.
underline. Wait. So light is a
Yeah.
wave and it's an energy. Right. So what is wave then? A wave is a disturbance. Do you know what's the meaning of disturbance?
No.
Dis- Disturbance is something like change. Sometimes you say to people,
Mm-hmm.
hear me. Does that make sense?
No.
Disturbance, okay, no problem. It says wave is a transfer of energy through a space or a medium. And I suppose you know what a space means and what medium means.
Mm-hmm.
So wave, a transfer, something, a transfer what? A transferring mass or energy? No, it's transfer energy. Now when I'm talking, I'm making wave. And this wave, it comes to your ear as a wave. So this wave is transferring this sound energy.
Okay.
This light can be
Yeah.
transferred in a space or a medium like water or air without permanently moving the particles of the medium, carrying energy from one place to another. So wave is something, is a disturbance transferring energy from one point to another point. So light, for example, is coming from any source of light, say for example from sun, it's coming to your eyes as a wave. So this wave is transferring this light energy. Is that okay?
Mm-hmm.
For light,
Yeah.
light can be transferred through a medium or through vacuum. Do you know what's the meaning of vacuum?
Uh,
Do you know what's the meaning of vacuum?
Honestly,
can you explain it?
Vacuum, when there is nothing.
No.
Vacuum means absolutely there is nothing, even air, something
Yeah.
totally free from anything. That's the meaning of vacuum.
So the meaning of vacuum is there is nothing.
There's nothing, there's no any particles. There's no any particles. There's no air, there's no gas, there's no liquid, nothing.
Right.
So we talk about wave. Can you see this image, this one? Can you see the wave? That's the meaning of disturbance. It goes up,
Yeah.
down, up, down, up, down,
Mm-hmm.
down, and so on.
Okay.
Okay? So by now, you need to know what is
Yeah.
light. Light is an energy, and it's transfer as a wave, and wave is a disturbance that transfers energy. So wave transfers energy through through what? Space or medium, like water or air. When I say medium, I mean anything. Okay?
uh,
Right.
Okay.
You have in your syllabus something says reflection of light. Right. What we mean by reflection? When light like that, can you see this? Can you see my pointer?
Yeah.
1 minute.
Mm-hmm.
and okay, that makes sense. Yeah. Okay.
Right. Can you see this word? Incident ray. Bayur. Bayar.
No.
Can you see this word? Incident ray.
نعم.
Right. So this light,
نعم. نعم.
Yeah, okay. This
Yeah,
light,
so the-
and you have
Yeah.
a mirror, this is a light, is, let's say, is hitting something like that, the mirror, and that light will be reflected back. The one which is reflected
Okay.
is called reflected ray.
Ray.
So we have like incident ray, and we have a reflection or reflected ray. Okay? And this one, this line,
Okay.
this is virtual, that's not real, but we draw it. We call it the normal. So there's an angle between the incident light and this normal, which is equal to the angle between the normal and the reflected ray. Does that make sense?
Yeah.
So the angle of incident ray is equal to the angle of the reflected ray. That's the law of reflection.
Yeah. So
Okay?
it's not equal. Okay.
Huh?
So it's not equal.
It's equal, equal. It's
It
equal.
doesn't look equal.
No, it's
Okay.
equal anyway. If it doesn't look equal, that's for you, but it's equal anyway.
Okay.
So that's called reflection of light. So we have something, say,
Okay.
called reflection, law of reflection. It says the law of reflection determine the reflection of incident light, and I suppose by now you know what's the meaning of incident light rays, on reflecting surfaces. Remember, this happened on reflecting surfaces like mirror. Like mirror. That's why you see
Mm-hmm.
yourself in a mirror. That's why you see yourself in the mirror.
Okay.
Okay? Or
Okay.
very small, very shiny metals, or sometimes a clear water. Sometimes you can see your image, your face, your body, when you look at the quiet level, a clean level of water. It acts as a mirror because it's reflecting the incident light, because it's reflecting the incident light. So what this law says, it
Okay.
says the incident ray, the reflected ray, and the normal lie in same plane. Can you see they are on the same side? Can you see they are on the same side?
Mm-hmm.
Do you understand why
Yeah.
I'm? So when we have incident ray, the reflected ray, it comes on the same side. It's not going to the other side. It's not going to the other side. I mean the other side of the mirror.
Oh,
And says the angle
yeah.
of incident is equal angle of reflection. Okay?
Okay. Yeah.
Right. Right. You have in your syllabus something says translucent. I don't know exactly how you pronounce it. Translucent surface. What is that? Let me clean this. How can I clean this?
Translucent surface.
Yeah, translucent surface. Just 1 minute. Let me clean this.
Okay.
Sometimes you have like a window. Look at these.
Like you can see through.
Yeah, you can see through, but not all the light passes through. It says allows light to pass through, but scatters. So what's the meaning of scatter? Scatter, it means the light goes,
Like it moves it around.
say again, sorry.
Like when it scatters, it moves it around so it won't be in the same direction.
Yes, that's what I'm saying. Exactly. Very good. Very good. So that's the meaning of scattering. And
Yeah.
this is the reason why we see the sky is blue. Otherwise, the sky is not blue. The sky has no color. But because light is scattering, sunlight is scattering, so that's why we see it blue. So
Okay.
objects are, yes?
Now,
Yeah, do you want to say something?
no, I just wanted to know what you said.
Okay. So objects on the other side aren't seen clearly. So you don't see clearly. Look at this window or this window, you don't see the other side clear. That's because of scattering of the
No.
light.
Okay.
Okay? What's the opposite
Yeah.
of this translucent surface? It's transparent. The opposite. Is that clear?
Yes.
So you have two words, they opposite each other. Transparent, you see everything. It means it's clear. The opposite is in translucent surface.
Mm-hmm.
Right. Is this slide clear for you what I'm saying?
Yeah.
Good. Right. Now you know reflection. That's what we said now, reflection. Now we have something slightly different. It's called
Mm-hmm.
refraction. It's called refraction. So what is
Refraction.
refraction? Not a reflection. Reflection when it goes back on the same side.
Okay.
It's not going through the surface. It's not going through. Like mirror. When you look at the mirror, you see yourself. That's because of reflection.
Okay.
Now we have something called refraction. Now, if you put say a pen in a cup of water, how do you see
Yeah.
the pen? Do you see it as straight or something like broken?
Broken.
Right? Yeah, this is because of refraction. This is
Okay.
of refraction. Look at this picture. You have this incident ray. You have a boundary. Do you know what's the meaning of boundary?
Like, is it like the air?
Is the border between two different things, like between air and glass or
Two
water.
different.
That's called boundary. It's like a border,
Okay.
two different faces, two different
Yeah.
materials. Is that clear what boundary means?
Yeah.
Right. So when light incident ray, and when you have a boundary, two different boundaries, whatever are they, like air and glass, that light will be refracted by an
Okay.
will be refracted. It means it changed its direction slightly. It
Mm.
means change is. Can you see the direction for this incident ray has changed?
Yeah.
You see? So the incident angle is not equal to the refracted angle. It's not the same angle.
Okay.
Right. If you have like, let's say, power of observation, the light is passing from air to glass. It's from less dense to more dense. You know the meaning of dense, yeah?
Yeah.
Density. So what's happened to the angle? The angle gets smaller when it's passing from less density to more density. You see what's happening?
Okay. Yeah.
So what is this called? This is called refracted ray, not reflected, refracted.
Ref- Okay.
So refraction happening between two, say, two mediums, such as air and glass.
Okay.
Okay?
Yeah.
So we still talk about refraction. It says a question why light change its direction when moves from one medium to another. What's the reason for that? It says light change direction or refracts. So refracts means changing the direction. Reflection means it goes back on the same side. So this is happening
Okay.
when moving between mediums because, oh, because of what? Because its speed changes. So the speed of light in different mediums is different. It's fastest in vacuum and it depends on the material. So light has different speed in different medium. And in other words, light in vacuum has a certain speed, but it's not as same as in air and it's not as same as in water. That clear?
Mm. Yeah.
So light moves, from one medium to another medium, its speed will
Okay.
its speed will be different.
Okay.
Sir, when you're walking on a road and then you go on, say, on a sand, your speed
Yeah.
will be changed.
Okay.
You agree? Do you feel that?
Yeah.
So you're not going as speed as you're going on a road, on a surface road.
Yeah.
But this is what's happening with light. When it changes its medium, the speed for that light it changes. It gets less, slightly slower. That's the reason
Okay.
refraction.
Okay.
Okay?
Yeah.
So is the speed of light same in all mediums? Is it same? No, it's not. No, the speed of light is different in different mediums. So when is it fastest? It's in vacuum, it's fastest, or in gas, and slowest. Where is the slowest? In solid.
Would it be glass?
In glass, it's slower than
No,
vacuum.
I mean, diamonds slower than vacuum.
Say again.
I said diamond is diamond slower than vacuum?
Yeah, what I am saying, the speed of light is different in different mediums.
Yeah.
When the medium is more dense, the speed will be less. It makes
Slower.
it makes sense. So in a
Okay.
gas, for example, in a gas is faster than in water, and in
Yeah.
water it's faster than in a solid.
Mm.
Sure
Okay.
about this one.
Okay.
So the order from fastest to slowest, we can,
Mm-hmm.
for example, vacuum.
Is the fastest, and then
And,
air, then water, then glass, then diamond.
yeah. Is that okay?
Yeah, that's fine.
Right. In
Wait,
general, sorry, say,
can I just write that down real quick?
huh?
Can I just write that down?
Okay. I don't think so. You need to know this number. I don't know if it's in your syllabus, but I've seen it anyway. It's about,
The speed of light. I
it's
probably
about,
need that.
can you read this number?
Yeah, 300 million
Good. Meter per
meters
second.
per second.
Good, good. Okay, very good. Right, this is what we've been talking about wave. There is two terminologies. You need to know them in your syllabus. One is called wavelength.
Mm-hmm.
It's obvious from the name when you say wavelength. When you say length, it means something measured, for example, in centimeters. It is the distance, and because you're saying length, so it's the distance between two identical points. Listen to me carefully. It is the distance between two
Okay.
identical points. Let me anoint it for you. It's for example,
Mm-hmm.
it's for example between this point and this point.
Mm-hmm.
Okay?
Yeah.
Just 1 minute. Or it is this point and this point. Or it is this point and this point. I mean,
Okay.
this distance or this distance
Mm-hmm.
or this distance. Anyone, all same.
They're all the same length.
Yes.
Okay.
This is called wavelength.
Wait, okay.
Yeah. See, for example, this wave, for example, is not as
Accurate.
wave. See, the wavelengths are different.
Mm.
There's another
So,
terminology. Yes.
so if let's say the wave is smaller, like it has more bumps, what does that mean? Does that mean does that mean like the amplitude is higher or lower?
No, no. Amplitude is different than wavelength. Look at this one. For example, this is a wave. If I could,
Yeah.
this is, if I'm not good in this one. Probably they have the same wavelength, but different amplitude.
Okay.
I give you a good example. When you make your TV sound louder or your mobile louder, you're not changing
Yeah.
the wavelength. You're not changing the wavelength. You're changing the amplitude.
Oh, okay, okay.
Is that clear?
Yeah.
Yeah, because you're keeping the same sound, the same people coming to you, talking to you, same. So the wavelength, the frequency is same, but you make it louder. This is because you're changing the amplitude. The amplitude is the height. Is the height. It's something like this.
Okay.
So this one, see this one, has the same wavelength, but different amplitude.
Okay.
So the amplitude is the height of the peak, is the height of the peak.
Yeah.
There are two different things.
Okay.
Okay?
Yeah.
Right. Let me clean this. So you have wavelength and you have amplitude. And I don't
Yeah.
know, I haven't seen frequency in your syllabus. It's a frequency, just I make it very simple for you. Frequency is how many waves passing through one point within a second. It's like
Okay.
it's like you're standing on the main road and how many cars is passing from that point within, say, a minute. That's a frequency. How many times you go to swimming a week? You're going 3 times a week. So within 1 week, you
Yeah.
go 3 times. So that's your frequency.
Okay.
That clear?
Yeah.
Frequency means how many times within time. How many times you going swimming? You're going 3 times a week. So your frequency is 3 times a week. When
Okay.
we talk about frequency with waves, it means how many waves, we don't have swimming, how many waves passing through one point within a certain time. That's frequency. So you have a frequency, you have wavelength, you have amplitude. Amplitude, the other word for amplitude is intensity. When you're increasing your light in your mobile, when you do that, you're increasing the amplitude, the intensity of the light. You're not changing the wavelength. It is the same wavelength, but you make it more bright.
Mm.
Clear?
Yeah.
Say this one is different amplitude. They have all, you have three waves, all of them having same wavelength. They having same frequency, no different. Same frequency,
Mm-hmm.
same wavelength, but they have different amplitudes.
Okay.
That clear for you?
Yeah.
Okay. What can we know from the wavelength? What we can know from the wavelength? What we saying says from the wavelength, we can know waves energy level. Oh, that's important.
Okay.
So when you have different wavelengths, different waves having different
Mm-hmm.
wavelengths, it means they have different energies. Shorter wavelengths, listen to this, this is very important. Shorter wavelengths, it means higher energy.
Mm-hmm.
When you have different colors like blue, yellow, red, why they are different for your eyes? Because they have different wavelengths. Because
Mm-hmm.
they have different wavelengths. So different wavelengths correspond to different colors in the visible spectrum. Do you know what's visible? The light which we see. The
Okay.
red has longest wavelength and the violet has shortest wavelength. This is in your syllabus.
Okay.
Note. So the red one has longest wavelength. It means it has the lowest energy. And the violet has the shortest wavelength. It means the violet has higher energy than the red one.
Yeah.
Okay? Right.
Mm-hmm.
See, this is electromagnetic. You're not going through electromagnetic radiation, all of them. That's not in your syllabus. But you need to know the light is one portion, one part of this electromagnetic radiation, electromagnetic spectrum. You see the colors? You see the wavelength?
Yeah.
What is the red? That's the red. Can you see it?
Yeah.
Where is the blue or the violet? It's on the left. See the wavelength. For the blue is 400, about 400. For the red is about say 700. So which one is shortest? Is it the red or the blue? Of course, the blue
The red.
has
Of
higher.
blue.
Is it the blue or the red?
Blue.
That-
That's what it is.
yeah?
Yeah.
Recycle.
Goldie?
Hoping you don't remember
Okay.
when you do.
Right. I can stop here for a few minutes because this program is only 40 minutes. I send you another link and come through again and have a break, okay?
Have a break, guys. Have a cup of tea.
Did you hear what I said?
Yes.
Okay.
Oh, so yes.
So have a break for 5. I send you the link.
Okay, thank you.
Okay, Habib.
Have your tea.
Hmm.
Might be a bit hot.
Yeah, I think still is.
Put tea in it.
Is this herbal?
It's nice, you like it. I think you will.
Yeah, Tam is my friend. He's
Yeah, that's the same style.
Bayar.
Masala.
Even Iraqis now.
Naam.
Bayar.
He's not
Naam.
hearing you, so no.
I recorded this one. I will send it to you. I try to send it to you.
Okay, Baba, okay. Say loud and clear. Okay.
Okay,
Okay, yeah.
Thank you.
thank you.
Then the connection is not clear as well, so that could be a bit. Like just 1 minute